So hi everyone, I'm Donato Pellegrino from Zircuit. I'm a blockchain generalist, and today I will explain what Zircuit is, very briefly, and how to build an application on Zircuit. But let's start from the architecture of a rollup, of a general rollup. This is the architecture of rollups based on optimism. We are based on optimism, but it's a very common architecture for many other rollups too. A rollup is, the network of a rollup looks very much like an Ethereum network. It's made of nodes, and every node has an execution node that is just like Ethereum get, slightly modified depending on the needs of every rollup, a consensus node, and an L1 node. The L1 node is needed for the information that comes from the layer 1. You need to see that someone wants to deposit, or you need to use it for other reasons that we're going to explore soon. One of these nodes is the sequencer. The sequencer is a node of the network that has all of the parts I already mentioned. In addition to this, it also has a batcher and a proposer. Rollups rely on the layer 1 for data availability and state transition verification or validation. The batcher service is the service that updates the L1 with the new transaction data coming from the L2. And the proposer is the service that provides the new state routes that the L2 constructs after executing all the transactions that have been submitted. There are a set of smart contracts. The most important probably is the bridge. The bridge allows you to deposit and withdraw any kind of asset or general transactions. There's a state transitions manager connected to the bridge to validate withdrawals that receives states from the proposer. And there is a verifier or challenge contract. Rollups divide themselves nowadays in optimistic and zero-knowledge rollups. They both try to solve the same problem, which is communicating to the L1 that a certain state transition is correct. Optimistic rollups optimistically consider a state transition correct if it has not been challenged before a week time. With zero-knowledge rollups exploit zero-knowledge proofs to verify the validity in a very small set of instructions that are run on-chain and that cryptographically assure you that the transition is correct. But what is Zircuit? Zircuit is a security-focused zero-knowledge rollup. What I mean by security-focused, I mean that we do a strong research on security continuously. We designed our architecture security first, and we also provide tools for users and the product and developers to keep their applications more secure on Zircuit. Our security stack includes a secure native bridge, monitoring of transactions for their safety, simulation of the transactions, as well as quarantining for the malicious transactions. And we also provide support for developers and users regarding their security setup. The main feature that distinguishes us from the rest of the ecosystem is the sequencer level security. The sequencer level security is a feature that works thanks to an AI oracle connected to the sequencer. The sequencer asks to this oracle for every transaction it receives from nodes or users if the transaction is secure or not. And the AI oracle answers saying yes or no. This keeps the chain safe from scams, rug pulls, hacks, not only the chain but also our own smart contracts. It's powered by a very big dataset of blockchain data collected on the past 5 years of many EVM chains, and it improves UX for everybody. It is totally transparent, and a user or a developer using Zircuit doesn't need to know anything about sequencer level security, even though it's there and it's protecting users. We are a fork of Optimism. We took Optimism, we removed challenge proofs, and we included, we added to Optimism zero-knowledge proofs. And our ZK stack is based on Halo2, which is used also by the PSC team, Scroll, Tycho, and it gives us a lot of advantages. We are able to aggregate very well. We have a dedicated GPU optimization that can be built into the pipeline with this. and many other things. This is our architecture. As I said, we have a sequencer that takes transactions from the L1 and the L2 nodes of the network and users. It's connected to the AI-powered analysis. It generates blocks that are given to the provers that generate the cryptographic artifact to submit to the verifier on chain to check the validity of the state transition. And the state proposer, that is the service that, as I said before, continuously updates L1 with the new state of the L2. A very important part of this architecture is the security through research. We do a ton of research on Zircuit, on infrastructure, on smart contract security, and on many other topics. And it always affects our development and progress. But let's get right into it. How do you build your own application on Zircuit? We're going to see tools, network parameters, network contracts, etc., etc. How do you do it? Have you ever built on Ethereum? It's just the same thing. The only thing you should remember is that there is a 2 seconds block time. Ethereum currently has an average of 13. Zircuit and optimism-based rollups in general have 2 precise seconds of block time. Which tools can you use? It's really straightforward. Zircuit.com is where you can go to understand everything you need. We have an explorer. Everything can be reached from Zircuit.com. We have a bridge. We have documentation that it's really useful if you are hacking today. We have a testnet, even more useful if you're hacking today. You can just add testnet in the middle of the URL to get to the explorer or the bridge, but you find the links on the website too. Here's an example of what you can find on the docs. You can find all the RPC parameters and alike. We have testnet contract addresses and mainnet contract addresses. You can find these things on the docs, and you can use them to operate to use the bridge as a user or as a developer. You can use any tool you want. I personally use Foundry and Hardhat. They work on Ethereum, they work on Zircuit. Anything that works on Ethereum works on Zircuit as well. So just use whatever you're already using there and you will be fine. So let's try the standard bridge. The standard bridge has 2 main functions. One is to bridge ETH and the other one is to bridge ERC20. We are going to see what happens when you just send ETH to the contract, so with the receive function. And what happens when you just want to bridge ERC20s. Let's get right into the code. So let me zoom a little bit. Okay. Here is how simple it is to deposit Ethereum on Zircuit from Sepolia. I set up this project. You can see I just installed contracts to have the ERC20 ABI, .env to set up some M variables, and Hardhat. I use these in this case. I've set up in Hardhat 2 networks, Sepolia and Zircuit testnet. Let's check out how to deposit it. You just get your signer, and then you literally just send a transaction to the bridge. In this case, the bridge address is this. You can find it in the documentation. It's really simple to find. I'm sending, for example, 1 Ethereum, and that's it. You just send this transaction, and Ethereum will appear on deposit ETH. There you go. And Ethereum will appear on the network. So let me just see how much ETH I have right now. We are on Sepolia, and I have 8 ETH, and we should see it become 7. I had 22, if I'm not wrong, on Zircuit. And there you go. So now the transaction is being sent to Sepolia. It's being used in the bridge. It went through the sequencer level security. And here it's 7. And we should see on Zircuit testnet the increase to the 23. And we have now Ethereum on Zircuit, and you can use them for whatever you want. You can send them, you can use them for gas, etc., etc. The way to bridge Ethereum, ERC20s, it's as simple, almost as simple. You just need to have the ABI and the address of the bridge. Everything can be found through the, I have to zoom a little bit. Everything can be found through the website and through the Explorer, for example, on Etherscan for the ABIs, and you need the contract ERC20. So you just need to approve the spending of a certain amount of ERC20 tokens on the bridge, and then just send a transaction to the bridge. We are calling bridge ERC20. We are saying what's the local token and the remote token. You can find this information on the Explorer as well, and the amount we want to bridge. So at the moment I have, where is it? 73 USDT on Sepolia. Now this is Zircuit. I have 121 USDT. Let's just run the transaction. Ole. Deposit ERC20. Okay, so we are going to see that the transaction is sent still to Sepolia. In this case, it's just an approval, so it's not going to go through the sequencer level security because it's L1 transaction only. But the second one does go through the sequencer level security. If it wasn't hacked, it would have been blocked. And there you go. So now we should see a decrease of USDT here, and there you go. We just bridge ERC20s. How do you withdraw? The exact same way. So let me get you to the withdraw ERC20 example. But the withdraw ETH example, it's as simple. You just need a different address. In this case, it's a pre-deploy. And the same ABI will work. And you just call the same exact function on the bridge. And you don't need an approval because the ERC20 we use for these kind of things on Zircuit already know that the bridge is a trusted contract. And we were just withdrawing, in this case, just 1 USDT. And let's just try it. Testnet. In this case, it's just 1 transaction. This transaction goes directly through the sequencer level security and, yeah, gets checked for safety. And there you go. We just withdrew. Okay, I was not on testnet, but here I am. Yeah, anyway, this number, it decreased. Okay, once you have done this, it's not finished for withdrawals. You need also to prove transactions and to finalize them. I did already some trials. So you can do this also through SDKs. You can use the Optimism SDK or other tools that are being developed right now to interact with the chain. Otherwise, you can just prove them on the Explorer. It's really simple. You just get to the blockchain and L2, L1 transactions. I'm on a specific page because I needed this one. So you just execute this transaction on your there you go. And in this case, you proved to the Optimism portal that your withdrawal is valid. Then there is a little finalization period to wait for. Let's wait for the transaction to be confirmed. And there you go. Okay. Voila. And that was the proving transaction. Let me reload it for a little bit. And we can also finalize transaction. And this is the actual transaction that gives you the USDT. In this case, just 1, because it's what I was bridging before. And we have 111 USDT at the moment. And if we execute this transaction, we should see another USDT appearing on my balance. There you go. We have now 112 USDT. Okay, so this was how to deposit and bridge. If you're looking into hacking today on Zircuit, you can do something that you want to do. You do not need to use only ERC20s or 721s. The standard bridge allows you to bridge any kind of, ERC20 or 721s. You can even deposit or withdraw your own ERC20s and 721s if you just create them on the opposite chain, depending on where you want to have your native token to live. You can make native tokens live on Zircuit or on L1, and you can use these two mintable contracts to deploy the counterpart on the other chain. You can use these things for this kind of stuff. Otherwise, if you want to implement your own logic, you can send normal transactions to DL1 and to DL2 by using the custom main messenger or the Optimism portal on DL1 and the L2 to L1 standard L2 to L1 message passer on the L2. These ones allow you to implement your own logic. It might not be an ERC20 or ERC721, whatever you want, you can deploy. So we have a build to earn program. You can get technical and financial support if you need, and if you are looking into deploying something on the Zircuit mainnet. We have a liquidity hub. You can stake on Zircuit and you can get some rewards such as staking yield, protocol tokens, points, and future airdrops. We have a bunch of partners. You can see them here. We do liquid restaking and liquid staking at the same time. We have more than 26 assets. You can deposit and withdraw your stake whenever you want. There is no lockup, and we even support some BTC assets at the moment. We are a team of gigabrains. We have a very, very security-focused team that does a lot of research on infrastructure security, on bridge security, roll-up security, on smart contract security, and on cryptography. A ton of research on cryptography for the proving of the zero-knowledge proofs. And that's it. Thank you so much. Check out our Twitter handles, and I hope you will have a great time hacking on Zircuit. And if there's any question, if we have time for questions, no, we don't have time for questions, so no questions. Sorry. Thank you.